Welcome to Unit 7. It's the study of right triangles in trigonometry, and today's lesson is on the Pythagorean Theorem and its converse. So hopefully you already know a lot of this. I'll just be refreshing your memory. All right, so let's review. What does the Pythagorean Theorem tells us? It tells us that if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So in other words, as we all remember, if ABC is a right triangle, then I know that C squared equals A squared plus B squared. And in this theorem, of course, C is always the hypotenuse. All right? You've known that for many years. All right, well, what you probably didn't know is that there is a converse to this theorem, and the converse just says the converse. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So if you were trying to use Pythagoras to prove that a triangle was a right triangle, then you'd have to use the converse of the theorem. And in this case, we know the converse says if C squared equals A squared plus B squared, then I know triangle ABC is a right triangle. Simple as that. Okay, so now I have something called Pythagorean triples. These are going to be very important to you, not just in this unit, but when you get to trig, pre-calc, you're going to need to remember your Pythagorean triples. So I'll write you some down here in a minute, and you need to make a flashcard so that you can remember them. But first of all, what is a Pythagorean triple? Well, it's a set of three non-zero integers. Integers, not a decimal, not a radical, three non-zero integers that satisfy the Pythagorean theorem. We call that a Pythagorean triple. Okay, so for instance, 3, 4, 5 is a Pythagorean triple, right? Because if C squared equals 25, A squared plus B squared in this case is 3 squared plus 4 squared. That's 9 plus 16, that's 25. So we know this is a right triangle because C squared equals A squared plus B squared. But they're all integers, no radicals, no irrational numbers. So there are quite a few of these that you're going to see very often. And I'm here to tell you that if you don't remember these, you will run out of time on your quiz and on your test because you'll be spinning your wheels doing the Pythagorean theorem when you don't have to do it. So I'm going to write down the most popular here, and you're going to have to memorize them. So what else? We got 5, 12, 13, 7, 24, 25. We got 11, 60, 61. What have I not got? 9, 40, 41. And I got 5, 12, 13. How about 8, 15, 17? So if you'll memorize these, you'll have it made with respect to the Pythagorean triples. Okay, got some example problems here. Find the missing length of the right triangle. Find them. That's kind of worded funny. We want to find x here, people. We want to find the missing leg length, right? We got the hypotenuse is 25. And then the question is, do the side lengths form a right triangle? Well, we just looked at the triples, and if I'm not mistaken, 7, 24, 25 was one of them, so we're not even going to bother to do the Pythagorean theorem. We know that x equals 7 because this is a triple, so yes indeed. And the more you write it, the more you'll remember. So if you'll say 7, 24, 25, is, and you could call it a PT, a Pythagorean triple. That's good enough for me. All right, how about this one? 8, 15. Didn't we also have 8, 15, and 17? We sure did. X is 17, so yes, 8, 15, 17 is a Pythagorean triple. And if you don't believe it, guys, put it into the theorem and check it out. See if 17 squared really equals 8 squared plus 15 squared. And you'll find that it does. All right, what do we have next? The legs of a right triangle have lengths of 10 and 24. So let's just draw that picture. So that'll be 10. We'll make this one 24. This is our right angle, and so here's our hypotenuse. What is the length? So that's what we're trying to find. We'll call that x. Okay, let's look back at our list. Is this a triple? It's not on my list. So here we go. 10 squared plus 24 squared equals x squared. So that's 100 plus 576 is x squared. So 676 equals x squared. So what is the square root of 676? It is 26. So x is 26. So what's the definition of a Pythagorean triple again? A set of 3 non-zero integers that satisfies, well, aren't these 3 non-zero integers? Yeah, they are. So this is a Pythagorean triple. Now let me show you something really special. What if I divide each of these by 2? If I divide 10 by 2 and 24 and 26 by 2, what do I have here? I got 5, I got 12, and I got 13. So, I remember 5, 12, 13 is a triple. So the point I'm making here is that multiples of the triples are also Pythagorean triples. So let's go back just a minute to where we wrote down these triples, and let's look at these. So for instance, we just did 5, 12, 13. We multiplied each one by 2, and we found out that it's another triple. But if I multiply each side length by 3, I still got a triple. By 4. So as long as you multiply each side length by the same number, you're going to have another triple every time. So for instance, I know that 6, 8, 10 would be a triple. I know that 18, 80, 82 would be a triple, right? I just multiplied this one right here by 2. All right, if I multiplied everything here by 3, I'd have 21, let's see, 3, that's 2, 72, 75. That would be a triple. So hopefully you get the point I'm making here is that as long as you multiply each side length by the same positive integer, you're going to have another triple. Alrighty. So now we got another couple of theorems. The first one said, actually this is the second one, but I like to do it better by starting with the acute and then going to the obtuse. If the square of the length of the longest side of a triangle is, let me see where I am, is less than the sum of the squares of the lengths of the other two sides, then I know the triangle is acute. So let's look at our triangle here. So the longest side, so let's say C right here is going to be our longest side. So all this theorem is telling me that if I know that C squared is less than A squared plus B squared, I know that triangle is an acute triangle. We'll do some practice with this just in a minute. All right, and then the obtuse theorem is almost the same, except it says that if the longest side is greater than the square of the longest side is greater than, I did say less than, all right, the sum of the squares of the lengths of the other two sides, then the triangle is going to be obtuse. So, using notation, if c squared is greater than a squared plus b squared, then that triangle has to be obtuse. And if you think about it, that makes sense, because look at our angle C here. The wider I open that up, right, if I were to open this wider, then that means C is just going to keep getting longer and longer. So that's going to definitely be an obtuse triangle. Okay, some examples. A triangle has side lengths of 6, 11, and 14 feet. Is it acute, obtuse, or right? Well, the longest side is 14 feet, so let's figure out what 14 squared is. 14 squared is going to be 196, and that's c squared. All right, and then let's do a squared plus b squared. That's going to be 6 squared plus 11 squared, 36 plus 121, and that is 157. That's a squared plus b squared. So what do we have here? We have that c squared is greater than a squared plus b squared. So by the theorem we just learned, we know this has to be an obtuse triangle. Obtuse triangle. All right. Why don't you pause right here and do the next problem? Gotcha, didn't I? You forgot about the triangle inequality theorem. Look, 7 plus 8 equals 15. Remember, any two side lengths, the sum of any two lengths has to be greater than the third side, and that's not the case here. So this is not even a triangle. So it can't possibly be acute, obtuse, or right. Gotcha. I may not have gotten some of you, but I bet I got quite a few of you. All right, here's a little bit more extra practice. Let's see, what I think I might do is I'll do the first one, and then you can do the next three on your own. Classify the following triangles. Oh, we're just doing more classifying. Okay, well, it looks like 8 times the square root of 15 is going to be C. And how do I know that? Because the square root of 15 is almost 4, and 8 times 4 is 32, so that side length is almost 32, and both of these are shorter than that, so I know that's got to be my longest side, even though I'm not really good at radicals, or you might think you're not. So let's figure out what that is first. C squared is 8 times the square root of 15 squared. So what is that? It's 64 times 15, right? I square that radical and I square 8, and that gets me 960. 960 units of some kind. Okay, now let's do a squared plus b squared. That's going to be 24 squared plus 8 times the square root of 6 squared. So 24 squared, I think we just had that a minute ago. Yeah, that's 576. And this is going to be, this right here is going to be 64 times 6. 64 times 6 is 384. And when I add those together, I get 960. So what are we seeing here? That c squared equals a squared plus b squared. So we know we got ourselves a nice right triangle. Okay, as I said, I am going to save these three problems and let you do them. I'll put the solutions here. You check back, and then I want you to write your summary, your essential question, and whatever you do, make that flashcard with your Pythagorean triples so you can drill yourself on those. All right, here we go. Be sure to check your answers. If you have any questions, you didn't get the things I got, or you just need to discuss it, please be sure to remind me in class tomorrow, and we will see you next time when we talk about special right triangles.